In this video, we're going to talk about stoichiometry with regards to mass and converting from the unit of mass from one of our reactants using a mole ratio to find another mass of either our reactants or our products. So in our first example, we are given a reaction. It is unbalanced, and you should be able to, in our assessments, balance the reaction before we do any of our stoichiometry. So get used to doing that. And then in this question, they're asking you to find the mass of hydrogen gas in this reaction that would produce 50 grams of ammonia gas. As I mentioned earlier, you have to balance this reaction. And when I balance it, I would have the coefficient 3 in front of H2 and 2 in front of NH3. Now, what I like to do is always write down below either the reactant or products what I'm given. I'm going to write down the values just so that I have a better understanding of what the question is asking me to do. So I'm told that the mass of ammonia is 50 grams, 50.0 grams, and they're asking me to find the mass of H2. So starting off, I'm going to start off with the number that I'm given in the question, which is 50 grams of NH3. And I'm going to write down also the unit that I want to end up with, which is grams of H2. So somehow, using our unit analysis, I want to get rid of my units of grams of NH3 and instead have the units of grams of H2. Now, usually always, if we want to convert from grams of something, you have to use our molar mass. And if I want my grams to cancel out, I want the mass of that molar mass to be at the bottom and the value of moles to be at the top. So for every 1 mole of NH3, which is the compound that we have here, there are 17.04 grams. And I got the 17.04 grams from the periodic table. Now, I've canceled out my grams of NH3. The unit that I am left over with is the moles of NH3. However, the grams that I want, the compound that I want to end up with, would be H2. So how do I go from this unit, the moles of NH3, to eventually to the grams of H2? I have to use my mole ratio. So if I want to cancel out the unit of moles of NH3, I'm going to write that on the bottom. And I want to end up with the unit of moles of H2, right? There's no way that I can go from moles of NH3 directly to grams of H2, which is why I have to use my mole ratio first. So in 2 moles of NH3, that's according to my coefficient, there are 3 moles of H2. So now I've gotten rid of my units of moles of NH3, and I've got moles of H2 that's left over. How do I go from moles of H2 to grams of H2? I have to use my molar mass again. This time, I want the moles to cancel out. So my 1 mole of H2 goes at the bottom, and for every 1 mole of H2, it weighs 2.02 grams, right? Because there's 2 hydrogens here. I got this value from the periodic table. So this and this cancel out. So if I multiply all of the top on the calculator, so 50.0 times 3 times 2, divided by 17.04 divided by 2, I will get the value 8.89 grams of H2. And there's 3 significant digits in my question, and there are 3 significant digits in my answer as well. All right, let's try a second example. If you want to pause the video and give it a shot yourself, and maybe you can come back when I'm taking it up. As I've mentioned earlier, the first thing we have to do is balance out this reaction. So let's write in our coefficients. So you should have 2Al, 3Cl2, and 2AlCl3. Just like I did in my previous question, I'm going to write down all of my given values underneath whichever chemical compound that I'm given it for. So in this case, 60.0 grams of aluminum metal. So I'm given this value here. And I'm asked to find the mass of aluminum chloride. So mass of aluminum chloride is question mark. So let me write that again. So I want 60.0 grams, or I have 60.0 grams of aluminum, and I want to end up with grams of AlCl3. So what would I do in order to go from grams of aluminum to grams of AlCl3? First of all, I need to convert the aluminum into a value in moles. And I can do that by using the molar mass of aluminum. So when I'm using the molar mass, I can use that to cancel out the grams. So 26.98 grams of aluminum in every 1 mole of aluminum. So what I've done now is converted this into moles of aluminum. And when I have moles, I can easily use my mole ratio to then convert it into the moles of AlCl3. So using my coefficients in my balanced chemical equation or reaction, I've got moles of Al at the bottom so that these can cancel out, and then I'll have moles of AlCl3 at the top. The coefficients are important, so for every 2 moles of Al, there are 2 moles of AlCl3. So technically it's a 1-to-1 ratio. I'm just writing out the 2's just because to be consistent with our balanced chemical reaction. So I've now have the unit moles of AlCl3, and I need to get to grams of AlCl3. So what I would need to do that, again, is our molar mass. So I'm going to, in this case, put the moles at the bottom. So for every 1 mole of aluminum chloride, that cancels out, I can have 133.33 grams of aluminum chloride. Now, this value I got from the periodic table, and when I multiply all of the numerator and then divide by everything in the denominator, I should get the value 297 grams of AlCl3. There are 3 significant digits in the question, and there are 3 significant digits in my answer. Now, this next example is similar to the ones we've done previously. However, they're asking you for something a little bit different. So they're giving you the mass of S8, which is 2.5 grams. 2.5 grams of S8. And they're asking you how many molecules of sulfur trioxide you will get if this much mass of S8 reacts with enough oxygen. So molecules of SO3 is equal to question mark. That's what I'm trying to find. Now, just like we've done previously, we're going to balance out our reaction first. The coefficients would be 1, 12, and 8. So now that I have a balanced chemical equation, I know what I'm given, I know what I'm asked to find. I'm going to start off with the value that's given to me in the question, which is 2.5 grams of S8. And I want to end up with molecules of SO3. Now, how do I go from here, from grams of S8 all the way to molecules of SO3? I can do it step by step. My first step is to get rid of the units of the grams of S8. And I can do that using my molar mass of S8, which is 256.56 grams for every 1 mole of S8. And I got this from my periodic table. Now I've got moles of S8, but I need to find molecules of SO3. So I can use my mole ratio between S8 and SO3 to now convert to moles of SO3. So for moles of S8 to moles of SO3, I can use the coefficients that are in my balanced chemical reaction. So for 1 moles of S8, there are 8 moles of SO3. That is my mole ratio. So now my value of moles cancels out for S8. What I'm left over with is the moles of SO3. Now that I have the moles of SO3, how can I convert to the molecules of SO3? What I have to do is use Avogadro's number. And what Avogadro's number tells me is that for every 1 mole of SO3, there will be 6.02 times 10 to the power of 23 molecules. Why am I using the unit molecules? It's because we're looking at SO3, which is a molecular compound. And whenever you have molecular compounds, the type of particles that we have are molecules. So now that I can cancel out my moles of SO3, I can just solve this or type this into my calculator to get the value 4.70 times 10 to the power of 22. There's 3 significant digits in my question. There are 3 significant digits in my answer as well.